Yeah, we will show that 1 plus 4 plus 4 square plus 4 to the n minus 1 is equal to 1 over 3 times 4 to the n minus 1 for all natural numbers. We're going to prove this by the use of principles of mathematical induction. So the first step is our basis step. For the basis step, we're going to show that n equal to 1 is true. So we're going to take the n's. We have 4 to the n minus 1. And that should be equal to 1 over 3 into 4 to the n minus 1. What we're going to do at this stage is that we're going to substitute 1 for n. Wherever we see n, we're going to put 1. So this is going to be 4 to the 1 minus 1 equal to 1 over 3 into 4 to the 1 minus 1. And that leaves us with 4 to the 0. So 1 minus 1 equal to 1 over 3 times 3. All right, so anything raised to the power of 0 is 1. 1 over 3 times 3 is going to be 1. So this is therefore true. All right, our next step is our inductive step. In the inductive step, we will show that if P of k is true, then P of k plus 1 is also true. All right, so we're going to go on to the inductive step. I'll write it over here. So we're saying that P of k implies that P of k plus 1 is true. All right. So first of all, we're going to rewrite the question in terms of k. So we have 1. So wherever you see n, we're going to put k. So 1 plus 4 plus 4 square plus 4 to the k minus 1 is equal to 1 over 3 times 4 to the k minus 1. All right. That will be P of k. Now we're going to show P of k plus 1. So P of k plus 1 would be the next term in the sequence. All right, so P of k stops at 4 to the k minus 1. Therefore, the next term in the sequence is going to be 4 to the k plus 1 minus 1. All right, so let's look at that. So let me just change the color as well. So for P of k plus 1, we're going to have 1 plus 4 plus 4 squared plus 4 to the k minus 1. And then we have another term because it's P of k plus 1. So we have plus 4 to the k plus 1. So adding 1 to the 4 to the k, add 1 to the k. We will put back the minus 1 that was there before. Minus 1. And that will be equal to 1 over 3 into 4 to the k plus 1 minus 1 here. All right. So now we are going to work the left side to have it looking at like the right side. So if we observe here, all that we have here is the same thing that we have here. So therefore means that we can replace what is underlined here with what is on the right side over here. All right, so we're going to use this to replace it. All right, because this is the same thing as this, which is here. So we have here 1 over 3 into 4 to the k minus 1. All right, so that's going to be used to replace this. Plus 4 to the k. All right, because 1 minus 1 is 0, so we are left with just 4 to the k. Good. Then we're going to continue. So that's going to be equal to 1 over 3 into 4 to the k plus 1 minus 1. All right. So what we're going to do at this stage is we're going to add these two numbers together. As you can see, there's a fraction over here. So this is the same thing as 4 to the k minus 1 over 3 plus 4k. Right? So let's continue. So if you want to rewrite it as a fraction so it's more visible, so we could do that. So it's going to be 4 to the k minus 1 all over 3 plus 4 to the k is equal to 1 over 3 into 4 to the k plus 1 minus 1. All right, so as we can see here now, we have a fraction, two fractions, so we're going to add them. So I'm going to take the LCM to be 3. All right, so 3 into 3 goes 1, so that's going to leave us with 4 to the k minus 1. All right, so this goes in here 1, so we're going to use the 1 to multiply this. And 1 times anything give it back itself. All right, so that's how we end up with the 4 to the k minus 1. All right, over here now we have 1 into 3 goes 3 times. All right. Now we may be tempted to just use the 3 to multiply what's up here, and that's fine. However, because we are dealing with indices, if we try to multiply 3 by 4 to the k, you will end up with a little problem. So what we try to do is to try to express this in terms of 4 as much as possible. So if we have 1 into 3 goes 3 times, what we can do is that we could multiply this by 4. And if we multiply this by 4, to ensure that we have the multiplication by 3, we could just take out one of them. All right, so it's like saying 3 times, say 4. 3 times 4 is 12. Right? So if we go ahead and we say, instead of saying 3 times 4, we say 4 times 4. That means we'll be multiplying by an extra one. So therefore means that instead of having 3 4s, we have 4. So all we will do is just take out one of the 4s. So it's the same thing, which is 16 minus 4, which is 12. All right, just bear this in mind as we work through this. All right, so because we're dealing with indices, I'm gonna be using 4. So 1 into 3 goes 3 times, but I'm gonna write it in terms of 4. So let's say we have, I'll put a little bracket here. So we say 4 times 4 to the k. All right, and because I multiply by 4 instead of 3, I want to have to take out one of them. I have to minus 4 to the k. All right, because if I say 4 times 4 to the k, that would be me using an extra one. All right, so I have to take out that extra. All right, so that's going to be equal to 1 over 3 into 4 to the k plus 1 minus 1. And then now we have 4 to the k minus 1 plus 4 times 4 to the k is going to give us 4 to the k plus 1. So again, we should remember when you're multiplying indices, you just add the powers. Right? So if you have 4 times 4 to say the third, is 4 to the first. So that would be 4 to the fourth. All right? So bear those in mind. That's how we end up with the 4 to the k plus 1 here. And then we'll have the minus 4 to the k. All right? And all of that is going to be over 3. All right, and that should give us 1 over 3, 4 to the k plus 1. All right, so at the end of the day, both sides should be looking alike. All right, now let's see what we have over here. You notice we have 4 to the k here, we have minus 4 to the k. So that will eliminate the 4 to the k. So 4 to the k minus 4 to the k, and that will cancel out the 4 to the k. All right, so let me just write it for emphasis. So we have 4 to the k, and take this minus 4 to the k. And that's going to eliminate the 4 to the k. And right by the plus 4 to the k plus 1, put by the minus 1 here, minus 1. And all of this is over 3. That's going to be equal to 1 over 3 into 4 to the k plus 1 minus 1. All right. And we are pretty much there. So I'll continue on the right side. All right. So let's continue over here. So 4 to the k minus 4 to the k, that's 0. So we are left with 4 to the k plus 1 minus 1. And that's going to be over 3. And that's equal to 1 over 3 into 4 to the k plus 1 minus 1. All right. And that therefore means that both sides are looking alike, because 1 over 3 times this is the same thing as 4 to the k plus 1 minus 1. So conclusion is that this is true for all natural numbers, right? So for all natural numbers, this holds. So that's it. Thank you for viewing.